Okay, today we are going to start new lesson, that is third lesson, number system, right? So we'll see what is number system and why we have to use number system. I have sent you a small worksheet in your group. So from that, I am giving some question that you can do it. You can later you can take the printout. Doesn't matter. Today morning I send it, right? Okay, we'll start. So why we need a number system? Why we need a number system? Now, if you take, you know that computer can understand only ones and zeros. Computers can understand only ones and zeros. So what will happen when the computer, uh, usually when the computer getting these ones and zeros, like a electric signal, something like this, that actually CPU or the processor is getting a signal like this. So if it is 1, this is 0 like this, you will be getting a signal. The මේ signal එක තමයි process එකට යන්නේ. But this signal should be human readable. දැන් මේ signal එක මොකක්ද කියන එක මිනිස්සුන්ට කියවන්න පුළුවන් වෙන්න නිසා තමයි we are using a number system. Now 1 and 0, this is called binary number system. So everything is converted to this number system inside the computer. But actually ones and zeros are not going through the wires. නේ wires දිගේ ones and zeros නෙවෙයි යන්නේ current එකක්. ඒතකොට current එකෙන් represent කරන්නේ මේ විදිහට ones and zeros තමයි represent වෙන්නේ. So to understand that we need a kind of a number system. අපිට number systems ඕන වෙලා තියෙන්නේ මේකේ වෙන දේ තේරුම් ගන්න තමයි. So other than the binary number system, we have different types of number system to study. That means different types of number system we're using inside the computer. So the computer එක එක විදිහේ number systems භාවිතා වුණා, right? Okay, we'll take your books and write down a topic. Write down the topic, number system. Write down the topic, number system. Under that, write down digital devices represent everything as numbers. Represent everything as numbers. All modern digital devices use binary numbers and small unit in digital device is bit. The small unit in digital device is bit. Humans need different number systems. To interact with to interact with computers. Interact with computers. Continue. Humans can't remember large set of ones and zeros. Large set of ones and zeros. And because of that, other type of number systems got in use. Under that, write down first one, decimal number system. Now in this decimal number system, numbers from 0 to 9 will be used, 0 to 9, and the base value is, we are telling base value is 10. Right? In this number system, we have numbers from 0 to 9. 0 to 9 means altogether 10 numbers are there. But we are starting with 0, but we have numbers, altogether numbers, 10 numbers are there. So, and base value is 10. Now we can base value is 10 right? Under that write down decimal number system topic under that write down this is made up of digits. This is made up of digits 0 to 9. 0 to 9. The base value of this number system is the base value of this number system is 10. Then next one write down binary number system. Binary. So here we have values from 0 to 1 and we are telling base is 2. Write down under that binary number system. Binary number system has two values 0 and 1. 0 and 1. And the base value is 2. And the base value is 2. Then write down next one. Octal. Octal number system. So here actually we have numbers from 0 to 7. Altogether 8, but 0 to 7. Base is 8. So under that write down. The digits are in octal number systems are the digits in octal number systems are the digits in octal number system are 0 to 7. 0 to 7. And the base value is 8. And the base value is 8. Write down next one, hexadecimal. Hexadecimal number system. Hexadecimal number system. So here you have values from 0 to 15 and base is 16. But there's a small difference now. 0 to like up to 9 it's okay. But when you're starting from 10, 11, 12, 13, 14 and 15, you have to represent these numbers with capital English letter. So 10 means A, 11 means B, 12 is C, like that. 13 is D, 14 is E, and 15 is F. So this is how you are representing if you get from 10 to 15 numbers in hexadecimal. Write down under that hexadecimal number. The base value is 16 and the base value is 16 and digits are from 0 to 15. Digits are from 0 to 15. Ten to 15 can be represented. 10 to 15 can be represented by using English capital letters as follows. Take this down. 0 to 9 doesn't matter. From 10 to 15 you have represented with capital English letters. Okay. Now suppose I am telling there's a number system. මම කියන number system එකක් තියෙනවා. Base value එක ඉතින් 12 කියලා. Base value එක 12 කියන number system එකක් තියෙනවා කියලා මම කියනවා. මම අහනවා what are the numbers in this number system? How many numbers are there? එතකොට what are the numbers? අපි numbers තියෙනවා 0 to 11. හැම වෙලේම මතක තියාගන්න එකක් අඩුවෙන් base value එකට එකක් අඩුවෙන් තමයි ඔයගොල්ලන්ගේ numbers තියෙන්නේ. හැබැයි ඔයා start කරන්නේ 0 වලින්. එතකොට numbers how many numbers are there? The 0ත් එක්ක ඔක්කොම numbers 12. හැම වෙලේම base value එකට සමාන numbers ගානක් තියෙනවා in a number system and values from 0 to 1 before base value. ඒ කියන්නේ දැන් අපි බලන්න පරණේව ගත්තාම octal number system base is 8. So numbers තියෙන 0 to 7. හැබැයි ඔක්කොම numbers 8. Hexadecimal 0 to 15 numbers තියෙන but all values are 16. ඔක්කොම numbers ගාන 16. So like that if you are getting any base doesn't matter, you can tell how many numbers are there and what are the numbers you have 0 to 11. දැන් මම කිව්වොත් මෙහෙම එකක් 0 to 14 තියෙනවා numbers 0 to 14. මොකද්ද base එක? Base එක එතකොට 15 නේ numbers ගාන 0 to 14 means all together 15 numbers are there. එතකොට අපිට කියන්න පුළුවන් base එක 15 කියලා. ඒ වගේ අපිට ඕන එකක් එම කියන්න පුළුවන් but you will be learning this binary octal decimal and hexadecimal number system solving. Okay. Then I will come for the conversions later. Then write down a topic most significant digit and least significant digit. Right? Within bracket put MSD and LSD. Most significant digit කියන එකට අපි කියනවා MSD. Least significant digit LSD. MSD and LSD. Under that write down most significant digit is the digit that contain the most positional value. That contains the most positional value. Most positional value in a number. In a number. Least significant digit is least significant digit is the digit that contains least positional value in a number. Okay, I'll take example and explain that. Here I'm taking a number. Now this is in this. Now before that I will tell you when you are writing a number, ඔය number එකක් ලියද්දී අපි base value එකක් කියලා කතා කරේ. You have to put a base value. As example, මම මෙහෙම ලියනවා. So you can read this 1100. මේක 1100 කියලා අපිට කියවන්න පුළුවන්. But if I put like this, මෙහෙම දෙක කියලා දාන පල්ලෙහායි. මෙහෙම දෙක කියලා දාපුවාම this is called binary. So you can remember base value එක අපි binary number වලට කිව්වේ දෙක කියන එක. So this is 2. 2 means it is base value is 2 means it's a binary value. එතකොට මේක අපි කියවන්නේ 1100 කියලා නෙමෙයි 1100. That is totally different value you are getting, right? එතකොට මේකටම අපිට වෙන එකක් දැම්මොත් මේ 8. This is octal. Right? This is hexadecimal. Like that we can put. But usually for the decimal value, decimal values වලට සාමාන්‍යයෙන් අපි 10 කියන එක දාන්නේ නැහැ. මෙහෙම 10 කියලා අපි දාන්නේ නැහැ. දැම්මා කියලා වැරදි නැහැ. But usually we are not using 10. එතකොට 10 කියන එක දාලා නැත්තම් අපිට කියන්න පුළුවන් මේක decimal value එකක් කියලා. If you get a base, then you have to, according to the base, you can tell what type of a number is that, right? So here we'll take this number. Now make a base value. I haven't put base value. Then you know this is a decimal value. Decimal value එකක් කියලා දාන්න. So each value you have a position value. Position value කියලා එකක් තියෙනවා. ඒකට අපි කියනවා මේක 10 to the power 0 position එක. මේක 10 to the power 1. මේක 10 to the power 2. Right? These are the positional value. එතකොට දශම තිතේ මෙහා පැත්තේ තියෙනවා. මේකට අපි කියනවා 10 to the power minus 1 position. This is 10 to the power minus 2. These are the positional value. දැන් මම ගත්තොත් එහෙම මෙහෙම number එකක්. 2. This is binary number. දැන් මම 2 කියලා දාලා තියෙනවා. This is a binary number. මේකේ positional value කියන්නේ කොහොමද? This is 2 to the power 0. This is 2 to the power 1. This is 2 to the power 2. This is 2 to the power 3. So මෙතනත් ඕනනම් කියන්න පුළුවන් this is 2 to the power minus 1. This is 2 to the power minus 2. Right? So you can have the positional value according to the number you are getting. Whether it's a binary, whether it's a decimal, octal, whatever it is, the base value will be coming here. දැන් අපි octal එකක් ගත්තා නම් මෙතන 8 to the power 0, 8 to the power 1. එහෙමයි අපි positional value කියන්නේ. Right? So just take this down, write down like this. The positional value can be represented according to their base value as follows. According to their base values as follows. මේක take this down as example. මේක දාගන්න example විදියට. Okay, right? Now you have to have an idea about this. Make an idea එකක් තියෙන්න ඕනේ. අපි MSD and LSD කතා කරද්දී. That's why I told this, right? Now we'll take the same sample. If you take a number like this, so most significant digit and least significant digit. So most significant digit කියන්නේ අපි කියනවා highest positional value නැත්නම් non-zero first value on your left hand side. So left hand side එකේ මේක. So this is called MSD. You have the highest positional value there. LSD means least positional value. එහෙනම් ඔයගොල්ලන් තියෙන්නේ 3 කියන එක තමයි least significant digit එක වෙන්නේ. Right? That has the least positional value. Right? If it is now, it should now, as example, if you get 0 here, 0 එකක් આવුත් එහෙනම් value එකක් නැහැ මෙතන. There you have to put the normal, you have to take the 2, value 2. Take this down, take this down. So this is MSD, LSD. Under that, write down most significant digit is non-zero first value on your left hand side. Non-zero first value on your left hand side. Least significant digit is last value on your right hand side. එහෙම කිව්වම ඔයගොල්ලන්ට පැහැදිලි ගොඩක් ඊට වඩා නේද? Right hand side. If you get a decimal or fraction value, if you get a fraction value or decimal point value, take non-zero first value on your left hand side. Take non-zero first value on your left hand side. As most significant digit. On your left hand side. As a most significant digit. And take non-zero last value. Non-zero last value. On your right hand side. on your right hand side as least significant digit. As least significant digit. Right? So if you get a fraction, I'll write here another example. You have to take the first value, doesn't matter, non-zero first value as MSD and the non-zero last value as LSD. As LSD. But if you get a whole number that is 310, there you MSD is 3, LSD you can take this 0 even, doesn't matter. For the whole number doesn't matter, you can take last position and that is least position value is 0. Here you can take as LSD. But if you get a fraction or decimal part, you have to take non-zero last value. Take this down as an example. Take this down as another example. And try to find out what are the MSD and LSD for these given 4 numbers. And put your answers in your Zoom chat. You can put your answers in your Zoom chat. MSD and LSD for these numbers. Find out them. First you take this down, this example also. Then write this down, take this down and find out MSD and LSD for each value. And put me the message on Zoom chat. Hurry up. Okay. Now here, most significant digit is 4. 4 is MSD. 6 is LSD. In this number, 5000. 5 is MSD and 0 is LSD. If you take this one, 3 is MSD, here 3 is LSD. Here 4 is MSD and 5 is LSD. I think now you can understand that. Even you get zeros in front of that, you are taking non-zero first value, right? So I think you can understand that MSD and LSD. There's another thing. There's something called MSB, LSB. Same thing. Same thing. The difference is MSB means most significant bit. A digit කියන එක නෝනේ දැන් වෙලා තියෙනවා bit කියන වචනේ එච්චරයි වෙනස් වෙලා තියෙන්නේ. LSB means least significant bit. Right? But same rules. දැන් අපි මේක use කරන්නේ binary values. අපි දැන් binary තාම කතා කරේ නැහැ. But binary values I told you, you are getting ones and zeros. Ones and zeros. Same rule we have to apply. In a non-zero first value, most significant bit, because this is a decimal fraction now. Non-zero last value. May one LSB. Right? If you get normal value, we got to take 1 0 1 1 0 here MSB is 1, here LSB is 0. The difference is MSB bit. This is related to bit, not digit. New paragraph. Most significant bit and least significant bit can be identified in binary numbers. Okay, take this down as example. Okay, right. Then we'll go to the number conversions. Now I think you can remember these number systems. So write down a topic: conversion between number systems. There, write down. First one, decimal numbers to binary. Decimal numbers to binary. So those who have done O-level ICT have done this stuff. But I will teach you from the beginning because there are some students who haven't done O-level ICT even. Okay. So if you get a decimal number, I'll take 25. This is the in decimal because I'm not using a base value here. I told you for the decimal numbers, no need to use base value even, right? So you can divide by 2. You are dividing by 2. So when you divide by 2, you get 12. And remaining value you have to put like this. Remaining should be either 1 or 0 definitely, right? When you are dividing by 2. So 25 divided by 12, sorry, 2, your answer is 12 and remaining is 1. Again, I am dividing 12 by 2, 6, your remaining is 0. Again 2, 3, remaining is 0. 3 divided by 2, 1, remaining is 1. So you have to put the value and the remaining value. Then you from the bottom to top, you can write down the answer 11001. But I told this is not 11,001, this is a binary number. So you have to put 2, base value 2 here. නම් මෙතන base value එක 2යි කියලා දානවා. මේක තමයි අපේ example එක for the decimal to binary. එහෙනම් ලියාගත්තනේ මා topic එක decimal to binary. Take this down as example. Take this down as example. Now here you have to divide until you can't divide by 2. අපිට මේ දෙකෙන් බෙදා ගන්න බැරි වෙනකන් තමයි බෙදන්නේ. දැන් මේ හරියට නතර ගන්න නැහැ මම. මේ බෙදාගෙන තුනක් බෙදුවාම එක කියලා ආවට පස්සේ එක දෙකෙන් බෙදන්න බෑනේ. There you have to stop. එතන ඉඳන් තමයි අපි උඩට ලියන්නේ. Right? Okay. We'll do some exercises. I have sent you the worksheet today. අපි ඒක පොඩ්ඩක් මම share කරන්නම්. ඒකෙන් අපි questions ටික කරමු. ඔයගොල්ලෝ if you can take printouts later even doesn't matter. පස්සේ හරි print මේව ගමු අපි. මම group එකකට දාලා ඇති මම share කරන්න. Okay, first three sums you have to do decimal to binary. Here try to do them 45, 89 and 56 and put me on the message, that is Zoom message. Send your answers. '89 you have to should get divide by 2, huh? 1011 001. '56 111 000. 11100. Those who have made the mistake can recheck where you have made the mistake. That means definitely you will be like when you are dividing by 2, sometimes you will be getting confused. That is actually mathematics, not ICT, right? Okay, so most of you have put the correct answers. Then I'll go to other one. That is decimal to octal. decimal to octal. So if you get a decimal value, we take 70. What you have to do is you have to divide by 8. Now earlier what we did, we divided by 2. Then දෙකෙන් බෙදුවා. දැන් එහෙනම් බෙදන්න ඕනේ 8. එහෙනම් 8ෙන් බෙදෙනවා. 70 වලට 8 into 8 64, that is 6 will be remaining. Again 8 divided by 8, 1, remaining is 0. එහෙනම් අර වගේමයි from the top, sorry, bottom to top. මේ පල්ලෙහා ඉඳන් උඩට ලියන්න. We can write the answers 106, but it is base value is 8, right? So take this down, decimal to octal conversion, and take this down example. Okay, we'll go to the worksheet. Decimal to octal. Do these three: 180 and 175, and put me the answers. Send me the answers. Okay, we'll see the answers. We have to divide by 8. So 100 you get 144, but put 8, right? Now in type, when you're typing, it's difficult to like subscript the letters, but when you're writing it, put the base value. Then 480, can write 120, and 175, 257. I think you can understand that. Okay, then we'll go to decimal to hexadecimal. Decimal to hexadecimal. Hexadecimal. There, if you get something like this, I'll take 170. 170. Same way you have to, but you have to divide by 60. 10 බෙදන්න එන්නේ 10 බෙදුවාම 10. Because you have type remaining also 10. So after that I can't divide. මෙතනින් පල්ලෙහාට අපි divide කරන්න බෑනේ. So we have to start from here. Then bottom to top you have to write. Bottom to top in this 2, 10 and 10 has come. So 10, when you get from 10 to 50, I told you you have to represent with English capital letters. So 10 is what? A. So I can write the answers A in 16. A in 16. So check what is the value here you are getting. And you have to represent with, if it is greater than equal or greater than 10 to 15, you have to use the capital English letter. Take this down as example. We will go to the questions worksheet. There are 3 questions. Decimal to hexadecimal 175, 268, 970. Try to do them quickly and put your answers. Okay, we'll see the answers. Here 175, when you divide by 16 you get 10 and remaining will be 15. So you can represent 10 with A and 15 with F. It should be AF, right? AF. Then next one, 268, it should be 10C. 10C. Then 970 should be 3CA. 3CA. Check your answers. Then we'll go to the binary decimal conversion. Write down the topic. Now you know any decimal value, if you want to convert it to hexadecimal, binary or octal, you have to divide by that base value. දැන් binary ගන්නවා දෙකෙන් බෙදනවා. That's the base value is 2 නේ. ඒ වගේ අපිට base value එකෙන් බෙදුවාම අපිට ටක් ගාලා ගන්න පුළුවන්. Then we'll see if you get a binary, how to convert it to decimal, right? How to convert it to decimal. Now I'll take binary value something like this. From right hand side you have to put the positional value. Now we are starting positional value is 0, 2 to the power 0. Here 2 to the power 1, 2 to the power 2, 3, 4, right? So each positional value you can put the values also. 2 to the power 0, any value power of 0, 0 power එක 0 කියලා කියන්නේ හැම වෙලේම 1යි කියලා අපි ගන්න. මේක 1 කියන ගන්න. 2 to the power 1 එනම් 2, 2 to the power 2 4, 2 to the power 3 8, 2 to the power 4 16. ඔය වගේ අපිට positional values ටික දාගන්න පුළුවන්. දාගෙන අපිට now here in this question එකේ අපිට තියෙනවා 1 කියලා තියෙන තැන් වල values විතරයි අපි මෙතනට ගන්න. So we have to take the values which is corresponding values for these ones. Okay, corresponding values ටික මෙතන 1 කියන එක ගෙන අපිට ගන්න පුළුවන්. I write here 1. මෙතන 0 නිසා ඒ value එක මොකක්ද තිබුණාද ගන්නෙ නැහැ. Here 1 is there, so corresponding value is 2 to the power 2, that is 4. So I am taking 4 also. මෙතන 1 තියෙනවා, 1 තියෙන value එක 16. Right? So you can add them together 21. So your answer is 21. This is the way of doing that. So but if you want, ඔයගලන්ට ඕන නම් මෙන්න මේ power එක දාපු value එක ලියන්න නැතුව මේ විදිහට 1 2 4 8 16 ඔය විදිහට දාන්නේ 16 32 64 එක විදිහට ඔය විදිහට ඉස්සරහට තිබුණොත් ඔය විදිහට දාලා ආපහු මේ විදිහට position value එක ගන්න පුළුවන්. Right? doesn't matter මේක පොඩ්ඩක් අර මෙහෙම ලියන්න ගියාම දිගට යන්න ඕනේ. But that is the meaning of that. So when you are doing the questions, doesn't matter, you can take it at once, right? So take this down as example, binary to decimal conversion. Okay, I'm going to share the questions worksheet. We'll do these three minus decimal. Put your answers. Okay, we'll see the answers. First one, you are getting 83. 83. Second one, you are getting 94. Check your answers. Last one, you are getting 121. So those are the answers. All of you have put the correct answer, I think. Yeah. Right? Okay, then we'll see octal to decimal. Write down the topic. Octal to decimal. So I'm getting this octal number. They are the same way, but here we are putting the positional value as 8 to the power. 8 to the power 0, 8 to the power 1, and 8 to the power 2. So here you get 1, here you get 8, 8 to the power 2 means 64. But there you have to multiply and take the answer. Multiply and take the answer. Now here 8 to the power 0 is 1. How many ones are there? 5. 1 into 5 plus 8 to the power is 8. But how many 8s are there? 2. So you have to multiply 64 into 1. Right? Then write down 64 plus 16 plus 5. So your answer will be 85. 85. Right? So no need to write like this. මේ වගේ වැඩි කර කර දාන්න ඕනේ නැහැ. උගලන්ට පුළුවන් කැලේම මෙහෙම මාස් එක අරගන්න. This is the method of doing that, right? Okay, take this down as example. Octal to decimal. We'll do some questions from the worksheet. Here you have octal to decimal. Start doing them and send me the answers. 125, I have done it earlier. So there is same 85 is coming. 203, 131 is coming. 45 you are getting 37. Okay, we'll write down the on the topic hexadecimal to decimal. Yeah, hexadecimal to decimal. So I'm taking example AC, right? So here 6 to the power 0, here 6 to the power 1. If you have more, 6 to the power 2, like that goes, right? Here you get 1, here you get 60. Here also you have to multiply and take the answer. Multiply and take the answer. 1 into C means how much? 12 plus 16 into A means how much? 10. So here you get 160 plus 12, altogether 172. 172. Take this down as example. Okay, we'll go to the worksheet. Here you have hexadecimal to decimal. 3 values are there. Do them and put your answers. Okay, we'll see the answers. First one, that is A5. When you convert, you are getting 165. F9, you are getting 249. Check your answers. A2D, you are getting 2605. So the whole line decimal value, right? Okay. So yeah, that's all for the today's lesson. We will be continuing this part now. Actually, this part, those who have done all ICT can manage, right? But we have more like than the all things. We have more things to do. Calculation, addition, subtraction, all these stuffs are there. Okay, we'll finish for the day. Please meet on next week. Thank you. Have a nice day.